Hey, thanks, Lance. Good morning, everybody. I guess it's still morning. Yeah. So, good morning. My name is Jeff Wilson. I'm the manager for systems engineering for rural in the Americas. Joined today by Drew Nelson, who is principal architect on my team in rural in the Americas, and we're here to talk about middle mile network architecture and how that's evolving. So, first off, I guess Drew, next slide. Um, this is the second in a series of webinars that we have going on. So today you get to look at Drew and I, and in 2 weeks you get to look at Drew and I as we talk about some of the topics that are key for rural networks in the Americas and capitalizing on those revenue opportunities. But just to begin, we next we're going to be here talking about the intelligent middle mile and the roadmap to success for that. And I think roadmap is a really good term for this because it's not something you're just going to build, drop in place, and everything is there. And going forward, it's going to be a technology transition as you build and evolve your network. And so, anyway, we're going to evolve the middle mile from where it is today. We're going to start by defining what that middle mile is and the factors that are leading to this evolution, and then some of the applications that are driving new revenue models, new opportunities, and the things that are not only here today but are coming tomorrow that you need to be ready to plan for. And then we're going to talk quite a bit about the intelligent middle mile and the importance of the intelligence piece of that really helps to drive that investment and to really monetize that investment in your network, not only short term but long term. So, next, Drew.
And I know all of that sounds super exciting, so we're going to try and make sure that we're keeping you all awake and make it a little bit fun for everybody too. I know these technical conversations can sometimes get a little bit boring and good for strong insomniacs, but we're gonna work to remedy that.
Yeah. So, Drew, what is the middle mile?
What is the middle mile? Well, I'll tell you what it's not. It's not the last mile. Last mile is more like things that you would see in a traditional access type network, right? So whether that be PON type passive optical networks, fixed wireless that goes from towers out to the endpoints, 5G, 4G wireless access, and even the last mile can be defined as a the last connection on an MEF style circuit, whether it be an Ethernet private line or a private LAN. It also isn't the first mile, right? So the first mile is more like the core of the network, right, where the applications and things that a lot of your customers want to use are, whether that be some of the things we identify here: Google, Netflix, data center type things. That's also not the middle mile. The middle mile, weirdly, is the middle. It's what connects those things together. It is a transport network that brings those services and those connections from the core of the network, from the services that you're, the service providers that your customers are demanding access to those customers themselves, right? And all of it can be, it all has different requirements and different needs based on the network.
Yeah, and
Middle mile.
each one of those is going to be unique, right?
Correct. Yeah.
Based on your geography, based on the capacity, based on the spread of your customers and where you need to carry that traffic to. So.
Yeah, absolutely right. A middle mile can have anywhere from short to long reach, right? It could be a middle mile that goes from one state to another, which is obviously a pretty big reach. Or it could be a middle mile where you have a statewide network that acts as one piece of the middle mile, and then a provider who's connected to that statewide network has their own essentially middle mile piece that goes between the statewide provider and the access network for their customers. So, it's hard to think of the middle mile as one network because usually it consists of several, right? It's only in the cases of maybe some of your larger tier one providers where middle mile would be considered even one contiguous network between the core and the access technology.
Yeah, and I think one of the keys also with the middle mile as we go forward is going to be this service awareness that's mentioned here, and this is where the network is able to then differentiate between that PON residential traffic and those business services, those MEF type circuits, and be able to address each of those differently and appropriately for whatever SLA you might have built around that. So this is the middle mile is really where a lot of that capability comes from.
Yeah, I agree. And it kind of threw in there in the core network, that network to network interface that you might see, whether that's to a middle mile network provider or to an upstream, whether it be a wireless provider or some other large network provider that you're directly connected to provide, quote, last mile services, even though a lot of the times those last mile services are going to ride your middle mile network primarily.
Yeah, so we keep talking about this transition, and originally a lot of the networks we work with in rural have been built like the access network over here on the left, where you had the access, you had kind of a 10G ring, everything went back to one place. That's not really the truth anymore, is it?
Not so much these days, but that seems to be the more traditional style. So you would have a ring technology, and you'd usually use some sort of layer 2 protection mechanism on there, typically like a G8032 Ethernet ring protection, or it's probably more fun to say an ERPS ring, as a lot of people like to say. It's kind of funny to say. So a lot of smaller providers, right? That was their whole network, was an access ring. Single access ring was able to encompass the entire network. It was always a little bit difficult to add nodes to it, right? Having to break the ring, bring in a new node, and bring the ring back up. Not necessarily the funnest thing to do during a 3 a.m. maintenance window. And it really kind of limited you on a lot of the technology that you could deploy across there, right? It's not very intelligent. You have a blocking port somewhere in the network. And that was it, right? So it was all there mostly for loop prevention, and the G8032 technology was there to detect if there was a cut and move that blocking port. That's really all it does.
There was very little service differentiation then as well, right?
Correct, right? You always went whatever way the blocking port said you went. There was no choice in that matter.
But now with the growth that we have and a lot of the demands that are out there with things like backhaul for 5G and faster PON speeds and other requirements like we'll talk about with low latency and some of those kind of things, the middle mile becomes much more important.
Right. So now what we're seeing with a lot of customers is, in some cases they're keeping these access ring type technologies, but they're hanging it off of a middle mile network, or they're just simply replacing that middle mile or that access type network with a more intelligent middle mile network that connects all of their nodes together. So if we look kind of on as that example on the right goes, some of the advantages we get from that is, a little bit more meshiness, right? So rather than just having a single backup path, you can actually have multiple backup paths. You could live with multiple cuts, or have less of a bandwidth impact on a single cut. You also can see here that this provider moved to more of a resilient network technology. So rather than having a single internet connection out of that backbone, they're able to run multiple internet connections, and they can use layer 3 technology to route traffic correctly, right? You can either, so it's maybe more than just active standby. You can have, idealized routing by taking in full route tables and taking the shortest path to whatever subnet your customer is trying to get to on the internet. Or you can still keep it just as simple as having, connection A is primary, connection B is secondary. Depends on the logistics of your individual network.
And with with layer 3 technology and some of the advanced protocols that are coming out now, you can optimize around many different things. It can be cost, it can be hops, it can be one of the keys on here that we mentioned was latency. And if we go to the next slide, latency seems to be becoming more and more important, and somewhat of a differentiator for services. And that's, if we look at this slide, that's a lot of the reason that we are seeing more of that mesh building within a network as opposed to a ring, is trying to not only trying to create some resilience by creating alternate paths, but more importantly, building more direct paths, because ultimately about 95% of latency is the fiber in the ground.
Yeah, transport latency is usually the biggest component of any latency. And this is obviously a super simplified example, right? It's you've got the ring on the left side, and you've got the ring with some collapsing in the middle on the right side, right? But even if you have longer connectivity between those nodes, what you can see is that latency changes, right? Rather than having a point-to-point latency from the left to the right of a full millisecond, you can reduce that to 7/10 of a millisecond instead, right? It's no big surprise that the shortest path between 2 points is typically a straight line. So being able to take that straight line will reduce the amount of time it takes for your packets to get from one side of your network to another.
So, though, if anybody's ever looked at the GIS data for fiber, it's never a straight line.
There is no straight lines. You've always got to follow. You're following whatever right of way is good for you, right? Whether it's a railroad, whether it's a highway, whatever. But it's there are no straight lines in fiber. That's for sure.
Yeah, and I think this has been proved out over time as well. A lot of this stemmed originally from high frequency trading, right? And companies that were trying to build almost perfectly straight lines of fiber from places like Chicago to New York, where they were cutting down that latency in milliseconds, because they found that if they could cut a millisecond or two out, they could that could be worth millions of dollars a year. I think if we hit the button one more time, I think we came up with like $100 million a year, right? And now you're not going to be providing this for major brokerage firms in most of rural America, but there are users of your network out there that would desire low latency services that would ultimately pay a premium for that low latency capability. So
yeah, and there are tier one service providers that are working on offering, building latency, low latency offerings, and offering that as a product even to consumers, something that you can buy as a consumer.
Yeah,
so you're right. I remember hearing a story about it was worth somebody's time to blast through some mountains to run a fiber directly versus going around them. Even though it was going to cost tens of millions of dollars to do so, they felt that the return on the investment was high enough due to the high frequency trading that they did it. They went ahead and bored through a mountain rather than going around it, just to save those few microseconds.
Yeah, it's amazing what money will do for you.
Yeah.
So a key now with the middle mile is not only the equipment that we use and we deploy in the middle mile, whether it's that optical line system to provide capacity or that the layer 3 network to provide that intelligence and service awareness, but it's also the control layer, right? The management layer, and building intelligence into that, so that we not only can we do the traditional EMS FCAPS type functions, but being able to take data out of the network and use it to measure performance against business objectives. Being able to do things like provide reports on how a network operator is meeting their SLAs. I know with some of the 5G providers who are buying backhaul services from smaller networks, they're requiring them to report on how they're doing with their SLAs. So building the intelligence into that management layer to allow for that measurement and to kind of automate that reporting is a key feature that we're going to need to have going forward, and it really is going to be all about the business objectives, not just the engineering objectives.
Yeah, and the technology has moved so much recently now, right? It used to be that the only way that you would be able to pull information out of your networks was using tools like SNMP, where you had to go out and pull, and you'd have a centralized system that would, like MRTG or something, that would give you utilization graphs, and it would be out there grabbing and pulling information every 15 seconds, 30 seconds, minute, whatever you had that set to. But now you have tools like BGP link state, or BGP-LS it may be called, where your network can communicate with your controller, right? You have path computation engines where your network can tell it, hey, proactively, you don't have to pull anything from me. I'm going to tell you that right now I just had a link between site C and site D go down. So tell the controller right now through BGP-LS that's happening, and you can build intelligence into that. You can build scenarios that says, if between D and C goes down, well, most traffic I'm willing to let it die, but I've got these premium customers who are paying me for an always-on service or a highly available service. I want you to move their services immediately over to a secondary path. Gives you higher, again, revenue opportunities for that type of high availability. As well as faster mean time to repair for them. Yeah. And it's important to talk about the multi-layerness to this, right? So not everybody is fiber rich in every part of their networks. Sure, the construction cost that we're seeing today is the primary component of any of these network builds, and the cost to put in 2 fibers is about the same as the cost to put in 288. But you don't always control every piece of your network, right? You may be using an IRU from one of those larger statewide providers, or you may have to cross a territory that isn't necessarily yours. And rather than having to lease a big bundle of fibers, you can use technologies like dense wave division multiplexing to be able to expand that capability and turn that single pair of fibers into 30 or 40 virtual pairs with channels.
Hey, Drew, Jeff, just while we're kind of almost halfway through, just want to remind everybody to please, take a look at that ask a question box. We got a decent amount of time left on the presentation, but we'd love to hear from you. So any questions you may have, please utilize that, and we'll be checking those as we go. Thanks.
Thanks, Lance.
Cool. Thanks, Lance. Yeah, anyway, if, when we talk about things like, the virtual fiber pairs and OLS and how it interacts with the routing layer versus layer one, we're also, the technology is creating some opportunities where we can do things like put coherent wavelengths in the routers instead of having to have the traditional demarcation between routers and the optical system. We can save a lot of cost, both CapEx and OpEx, by moving that coherent optic into the router and running it across dark fiber or across an open line system, or even over traditional ROADM systems, and running it either with the coherent optic in the router itself, or running it in parallel with transponders. There creates a lot of flexibility for your network, and it creates more flexibility. So you could probably offer wavelength services that go over transponders while having your routed services running on a coherent optic on your router itself to minimize that cost. There's just a lot of opportunities out there now with the technology that's been created.
For sure, right? With the advent of the OpenZR Plus optics, that where the manufacturers are, at least in theory, right, cooperating on their forward error correction algorithms so that they would be interoperable with each other. But more to the point, we've gotten to where we can shrink down a reasonable sized optic and amplifier into a QSFP DD form factor, right? So we're selling a a QSIF PDD that is about this big that has your 400 gig transceiver in it, in addition to a small amplifier that's able to get that signal up to a 0 dBm launch power. So, that lets you, if you are using an OLS, that lets you overcome some of the insertion loss you might see from a MUX and or a ROTEM without having to necessarily do any kind of preamplification on it. And even if you're not using an OLS, right, it still gives you a hotter signal that you can start your connection with, and you can go 80 plus kilometers without having to have any amplification. On top of that, we're starting to see amplifiers themselves even shrink in size, where you're going to have these compact OLSs, or maybe even able to turn your ports on your router into an OLS. I think coming soon we have an amplifier, an EDFA amplifier, that we're going to be able to put into a pluggable. So rather than having to have a whole separate shelf for an amplifier, you'll be able to do, not necessarily the highest performance amplifier, but enough to get you that extra 20, 30 kilometers of reach out of just a small pluggable.
And it'll be kind of single span stuff, but it'll be multiple wavelengths as well.
Mm-hmm. Yeah, it's full C-band spectrums.
Yeah.
But you're right. There is a piece to this that is, good for your revenue opportunities, depending on where you are and what your demand is. I would say most providers in our space are perfectly able to handle most of their customers' demands, but with MEF style packet circuits, right? Ethernet private lines, virtual private lines. But you're going to have sometimes customers who are going to want to have a wave service, or they want that, don't give me anything but the wavelength. And OLS and DWDM is, the best way to do that at an economical scale these days. You can just give them a dark fiber, right? That's always an option, but that, it becomes, you have to be willing to lose the fiber, right? Because you're not going to have access to it. It is, a piece of infrastructure that's no longer going to be available to you while they're using it. So.
Well, and providing wave services over your OLSs. Again, there's a lot of opportunity cost with that lost pair of fibers, and there's as that customer grows, and they may move from carrying a 100 gig wave to a 400 gig wave over that dark fiber. You're still charging them the same thing, but they're getting more value out of it. So moving to wave services at least allows you to kind of recoup some growth of your revenue as they grow.
Yeah. And, there's not everybody does this, but I've seen situations where, you lease the dark fiber and your customer puts their own DWDM system on it, and sometimes even ends up competing with you. You can do some contractual things to keep that limited, but it can happen. I've seen it happen.
Yeah. But, ultimately it comes down to revenue. And for a lot of our customers, it really comes down to the applications and the services they're able to offer.
So let's talk about that piece of it, right? What is it your customers want from you, right? It's problem that some of the big companies are starting, traditional cable companies, for the longest time, they were in the content business, right? They provided content. But now if you go ask a traditional cable company customer, what does he want? Just want bandwidth. Give me a dumb pipe.
Well, and quite frankly, those cable customers or those cable companies have found over time that providing content is becoming very expensive, and that's what they really want to start selling more of the bandwidth pipe and get away from providing the traditional TV services, because it actually costs them to have those.
The margins have eroded to the point where it's just not a very profitable service, and that's that's kind of what we're trying to show here. Is there are other profitable services that you can leverage your network to provide that might be able to provide more value.
And these pieces of pie are not scaled based on the number of services you'll provide, because probably the biggest chunk of this will be that little piece of pie there in the upper right, which is the best effort basic broadband, right? That's what you're going to sell to 95% of your customers. And it has very little demand and has very little differentiation. But when you start to look at some of these other things, whether it's looking at work at home or over on the other side, especially looking at things like streaming and immersive experiences, those are the places where if you can make the changes to your network to allow for them, then those become significant revenue opportunities, right? Those are the low latency connections. If you look at the inner part of the circle, and the real high speed connections as well. And so that's something where you can build a differentiated service that you can offer for a premium price. And you were talking about cable companies, Drew. I know some of the big ones are starting to offer that.
Mm-hmm.
And in fact, I was in a talk the other day, and one of those cable companies was talking about the big drivers of traffic on their network right now are two things: live sports streaming and gaming. And they had a list of the 12 biggest events in their network in history, and 11 of them were one of those two things. And the third one, or the 12th one, it was number 12, was a winter storm where, everybody was stuck at home. But the
Yeah, it was
biggest
interesting.
thing,
You were telling me about that. The number one was not, I would have thought that the number one would have been like a football game or some sort of live stream sports event, but you said it wasn't.
it was Fortnite. Yeah, it was a Fortnite live event. And it was, people streaming, watching other people play Fortnite.
Yeah, I have a teenager myself, right? And while he's always playing online video games, his second monitor is always some other stream, whether it's a YouTube video or him watching somebody else play video games. So yeah, it's again, it's what your customers want, right? They want that low latency.
And if it's one of these big cable companies talking about it, it's happening in the small rural networks as well, right? Those residential customers are looking for exactly the same thing. So we've got to help them build the capability and really in the middle mile to deliver that.
So hey, Jeff, we did get a question in, and it's quite a good question. Can you address how ribbons should be used to manage internal traffic flow so core services get the priority they need through the middle mile network, as well as edge service providers who may have much less bandwidth available to them? 10 gigabits per second on a 400 gigabit network can cause bottlenecks. VoIP packets should be prioritized, etc. And that's true, right? So here is where you're going to use some traditional quality of service, class of service type of marking and prioritization. So, the good thing about having a 400 gig backbone is that you're not going to see a whole lot of shaping, right? Your shapers aren't going to kick in very often inside your network because you've got the 400 gig connections. But you're absolutely right. You may have a handoff to either another service provider at the end or a smaller customer that is either a 10 gigabit or a 1 gigabit, and you may want to be able to prioritize the voice traffic or the real-time streaming traffic. So as with most network equipment, with Ribbon, you can use our system, whether it be through the Muse management system, to classify that traffic. So whether it comes in on a specific connection or whether it comes in on a specific VLAN, you can mark it with a higher class of service that would essentially put it to the front of the line. So that if a connection down to that customer was getting saturated at 10 gigs or 1 gigs, you would prioritize the voice traffic and or the video traffic, and as well as your internal control traffic, right? That's another one that you want to mark pretty high in priority, is the ability to control your own network.
But as well, that should be something that you're kind of watching for as well, right?
Mm-hmm.
And tracking the traffic that comes through that interface to make sure that, let's face it, to make sure that interface is scaled correctly for what that customer needs.
Yeah, and that's, in my experience operating a network, we usually had alarming set up at an 80% threshold, right? So we would, if we started to see a link get to an 80% threshold, we would throw a major alarm, and that would sort of signify to our engineering team it was time to look at an augment for that. But when it's your customer, an end customer that's getting a link from you, I can see where they may not want to spend the money on a new one. So now, having said that, usually doing traffic prioritization for those customers, that was usually a chargeable service, right? When we
Sure.
had end customers that required that, we would charge a premium for that service. Normally things were all best effort, but if you wanted us to prioritize this piece of traffic or that piece of traffic, we would charge extra for it.
Well, and that's that kind of differentiation, right? If they want to provide the right capabilities, and they're asking you to provide them those capabilities, that's where you have to charge a premium because you're going to do more work.
Mm-hmm. But with an intelligent system, you can make that work less impactful on your staff, right? You can have some pre-canned type of profiles that because as the person who asked the question said, VoIP packets should be prioritized, right? That's going to be almost across the board for everybody. So in the old DSCP markings, we usually mark that as EF, right? Expedited forwarding. So you would always put that near the top of the queue, if not at the top of the queue. But then you would also not necessarily reserve the entire bandwidth of the circuit for it, because especially today, your network is not going to be comprised bandwidth wise primarily of voice. It's you can fit 10,000 calls on a gigabit connection. Just don't see all that many. But if you put 5-10% as prioritized for expedited forwarding, you can always make sure that voice traffic flows.
Yeah.
And what you want to say about the kind of this mission critical, in addition to streaming, mission critical, how we see that as something like medical devices, right? There's a lot of options for home care now, and you can have devices that are monitored by doctors and by medical professionals, and it can be using that network connection to administer care. So that is the very definition of mission critical, right? That high availability is very required for them.
Yeah, and so if we hit the next slide, this kind of goes with somewhat with the question we just got, and being able to do some of that traffic engineering, some of that prioritization, and quality of service based on different types of traffic is going to be critical to keeping your customers loyal, and whether it's education and telehealth like you were just talking about, or it's somebody who always wants to be streaming as fast as they can go, setting up the right rules for them and throughout your network is going to be key. And whether it's minimizing latency and packet loss, or maintaining reliability well above traditional ring protection type reliability, or one thing we haven't talked a lot about here, but providing the kind of security that education networks really need. Those are all important network functions.
Well, sure, right, and that telehealth we talked about as well, right? If you have a device that's administering care and providing that health information, you want to make sure that that's happening in a secured method, and you'll hopefully you'll have that overall provider that does their own encryption on top of it, but you still want to make sure that you can offer the service to say, hey, if you need a higher security on this, whether it be tunnels, whether it be dedicated connectivity, make sure that that's available, right?
Yeah. And with the intelligence that we're building into networks today, and the advanced protocols that are being built into layer 3, and the management capabilities that we're working on, this is all very achievable in the networks that are being built today. So hopefully that helps drive positive revenue for our customers as well.
Yeah, again, with in the old days we used to call it differentiated services, right? And so when you offer those differentiated services, you can in fact charge extra for them. So kind of to the point that our question asker had said, how do we ensure that we have good traffic delivery for different types of traffic? So network slicing is one example of the intelligence that we can put in, and we can use different technologies even to provide slicing across the network in different ways, right? Here we define a hard slice and a soft slice. So there is technology called Flexi or flexible Ethernet that offers these hard slices where if you have a customer that says, I need you to give me 7 gigabits of traffic, and I need you to guarantee me that 7 gigabits of traffic is always mine. You can use flexible Ethernet to set that hard slice across the network, that 7 gigabits is cannot be intruded upon by any other service. It's probably the least common service. It's one of those where with the development of 5G networks, that was there was a big ask for that functionality. In my experience, I haven't seen customers demand a whole lot of that, but it's the technology is there. It is a doable thing. What really happens more is what we call this soft slicing, and that's where we can use technologies to build tunnels across the network. So you talk about being able to offer a low latency service or being able to route around congestion within your network. Typically, we're seeing things like segment routing, traffic engineering for that, right? So if you had say a 911 service that was across your network, and you wanted to make sure that had the fastest path and had a certain class of service and a certain quality of service, you could build that traffic engineering tunnel from the endpoints, right, where it goes out to the PSAP and then comes into whatever network-to-network interface goes up to the centralized provider. You build an SRT tunnel for them. You can set it as your highest priority, your highest class of service, and you can pre-build backup paths or primary or secondary, tertiary paths for it, so that if you have a failure in the network, there's essentially less than 50 milliseconds of switching time. However long it takes to recognize that problem exists is how long it's going to take to switch over to that backup path.
Yeah, and depending on depending on how you build the network, there can be the protocols that exist today can continue to find backup path after backup path, and especially with things like segment routing, you can still see that for a while. You can still see that 50 milliseconds failover that keeps all that up and running.
Yeah, and we're network engineers, guys. We love our acronyms. There's literally nothing in the world we love more than acronyms. So we'll try to explain the acronyms when we say them. But yeah, ask if we don't say something or not to your liking. Please just ask to elaborate. So I guess let's kind of sum up what we think about this intelligent middle mile concept and why we think it's important nowadays. So, service aware. You said that term earlier, Jeff. Let's redefine what do we mean by service aware.
Well, it just means that when you're going to have different customers with different requirements, right? And the network needs to be aware of what those requirements are. So if you have a business with an MEF service, they're going to have different requirements, different SLAs than your basic residential customer. And their traffic needs to be treated differently. It could be, if it's that 5G backhaul for T-Mobile or Verizon, they're going to have very strict SLAs. And you need to have the network able to identify that traffic, treat it an appropriate way so that you're meeting those SLAs and meeting those contractual requirements. And if there's a point in time where your network has to make a decision over what traffic passes and what traffic doesn't, it passes the right traffic and lets the lower priority traffic go.
Yeah. Another question that came in, also similar, to kind of building on the previous question. Don't lose sight that most networks are hybrid, with portions being fed with type 2 links for redundancy or desperation. I like that term. That are smaller than the fiber-fed pieces. You need to manage the smallest piece, correct? That's true, right? When you look at the flows inside your network, you need to make sure that whatever the weakest link in there is managed. So that's where you can use things like traffic engineering to make sure you have paths that build around it, right? If you have primary paths or other paths that are higher bandwidth, but you have those lower bandwidth paths that are still critical pieces of the network, you can prioritize the traffic that needs to go across those lower layers, those lower bandwidth paths with traffic engineering, and leave your best effort or your scavenger type traffic to go across the higher bandwidth links. It's always right. Engineering a network is always a trade-off. It's always about looking for what is your limitation or your lowest common denominator, and making sure you plan for what happens when even that fails.
Yeah, it's always about maximizing your biggest constraint, right? And getting the most value out of it and letting everything else work around it.
Yeah, in a lot of places you see those type 2 networks that he's talking about, and that's an old phone company term, type 2, right? That means when it's provided by somebody else, right? You've got another network provider that's giving you a service that's going from one side to the other, and so it's not necessarily within your control. I would say the most common example of that is a lot of people's, their uplink to their internet transit provider is going to be one of those type 2 style circuits, right? It's not usually going to be a 400 gig connection. It's going to be, either 10 gig or a fractional 100 gig. So you need to make sure that you're managing your traffic to that uplink, right? So as we talked about, the most popular service that most of these networks have is that basic broadband network. And so when you have your Thursday night Amazon Prime football game, and you may not necessarily have an Amazon distribution server connected directly to your network, you're going to have however many people on your network are streaming that football game. You're going to have that many streams going to your transit provider. So you've got to make sure you're managing that traffic. And so that's where, if you do have multiple connections and you're thinking it might be too much, where you may need to split your routing so that you're going across both of your providers, or going across multiple connections to that same provider. It's where you have to be a little more advanced in how you do your routing.
Yeah, and those are all going to be unicast connections, right? So there's going to be the same thing stacked up 10, 20, 100, 150 times instead of being something like an old school multicast.
Right. Yeah. There's a lot of, larger providers will often put one of those distribution servers within their own network. So it doesn't, they only have a single stream or two that goes to the distribution server, and then, it's all internal to their network.
Yeah.
The individual streams, but not everybody can do that, right? There's a lot of providers, and it's, those have a cost, and you have to kind of define, is it worth doing that for those one day, that 1 day a week, or is it better to just manage your traffic? And that kind of comes back to that flexible topology, right? As we're talking about this, and we move down the list, flexible topology, being able to have multiple internet providers or multiple drains out of your network, and being able to use it for more than just active standby, more than just a failover. Being able to manage that traffic and use best pathing with having multiple full internet route tables, right? Full visibility into your network of where your providers can go to, especially if you use different providers, right? If you have provider A and provider B, well, they may have different upstream views of the rest of the world.
Yeah, and the ability that then gives you the ability to shift on that one night a week during the football season, so that you're delivering, or it also allows you to shift for those events that pop up that you may not realize, like that Fortnite streaming event. Or I know there were a couple networks out there that really got hammered when there was a new release of Fortnite that dropped at midnight, and everybody tried to download it at the same time. Having that flexible topology allows you to balance that traffic as well. And having the intelligence in the middle mile helps you to forecast how your capacity really needs to grow, and it helps you balance those things out so that you don't have to react immediately, but you can build a forecast, and you can grow your capacity intelligently, and that helps keeps things economical. That keeps keeps the cost where it needs to be. When you have to do things, what is it? You want it done well, done quickly, or done cheaply. Pick two.
Yeah.
You don't have to pick two. Then you can kind of keep it balanced out.
Right. You can do more than just the old solution of throw bandwidth at it.
Yeah.
All right. So we've got a couple of case studies that we'll look at here from a couple of our customers that we worked with. One, we had a provider in rural Kansas, And when we first were talking to them, we were actually looking at doing a full DWDM network for them, right? They had, as as we've talked about here in some of the access stuff, they just had a 10 gigabit network for their entire network. And they were starting to get requests from the mobility providers to have 10 gig circuits for all their towers. And so they needed to look at something that was going to be more capable and able to scale and be able to provide more bandwidth. And when we did the math on it with them, 400 gigabit network basically became unlimited bandwidth to them. So we were able to size their network correctly and build in more optimized failover, right? As we said with the intelligent middle mile, we were able to use underlay technologies like TILFA and SRTE to give them the ability to have high bandwidth networks with high resiliency. And it worked out to be a little bit better than, a lot better than what they had before. But it also turned out that they didn't necessarily need that OLS or that DWDM layer underneath it. The technology had advanced to the point where that single 400 gig backbone for them was going to be plenty for their next 10 years.
Yeah, and even if I remember right, they were looking at some of the things that are coming down the pipe from 5G, right?
Mm-hmm.
Like the heavy IoT application of ag tech. That's why the combine's on here, right? There's a lot of agriculture and a lot of ag tech that's going into their areas. So building this network with the capacity and with the resilience was going to allow them to offer those services to their customers. And again, differentiable service.
Indeed. And then the last one we want to talk about, we had a Tennessee co-op broadband provider that had some different problems, right? They had older transport equipment that wasn't necessarily very easy to manage. It was all, each device was individually managed. So when you built services across the top of it, you had to go into every device to make configuration changes, and you had to make sure you were, saving those configurations and doing them correctly rather than having a single overarching management system. And in addition, their primary skill set people are much closer to the end of their careers than to the beginning. So they needed the ability to have some technology that would be teachable and learnable by newer workers, by people coming into the industry. And being a co-op, they have very limited resources, right? They don't necessarily have the ability to just go hire a bunch of people when they need it. So having
even when they hire those people, right, they're not hiring the same kind of people that they're losing.
Right. Correct.
And so, I think they've realized this. I don't think that all of our rural customers, I think they know it. I don't think they've realized it completely, but this is going to happen throughout the country, right? Where we have a lot of networking talent that is, as you said, closer to the end of their career than to the beginning. And the people that you're going to replace them with are going to have different skill sets. And so what you really need to be doing is building a network that lines up better with those incoming skill sets. So, the intelligence, like you said, the overarching management. So you have less human error because of less human touches. Yeah. Always a good thing.
And so real quick, as we're kind of wrapping up here, the solution we did for them is we did an IP MPLS layer 3 deployment, right? We were able to take advantage of EVPN all active multi-homing, just being able to use multiple devices for redundancy in each of their sites, all connected to their individual access devices. We used the IGP to handle upstream failures. So we had multiple internet connections that are coming in and out of there. And based on the IGP and the routing, we're able to handle failures within the network and always have an available path to the internet. So we're kind of running over a little bit. So let's summarize real quick.
A big thing, and we haven't talked about, BEAD or any of the public funding a whole lot, but it's out there. It's a very popular topic. One of the things that everyone needs to realize is that it's for CapEx, right? It's for buying equipment. It's for buying construction services and fiber and new equipment. There's no OpEx. There's no ongoing funding stream to run the network. So you're going to have to get that OpEx out of the savings of your operations and the increased revenue from differentiated services. Now, a lot of this technology, when we talk about taking out old legacy equipment and replacing it with new stuff, you're going to see a lot of savings especially in things like power and cooling. The amount of bandwidth that'll go through one of the devices today
versus watts per bit or whatever, right? It's way better, way more efficient.
Yeah, and then with the more advanced protocols that are out there running on a network, you're able to use what you have deployed much more efficiently, and so that's going to save costs as well. So that's a lot of your OpEx is going to come from those savings. But the key is that you've got to building the intelligent middle mile, and the intelligence is important, is what's going to keep your network running and help you grow revenue.
All right. Well, we already had some good questions, but if anybody's got some more, we've got to. We're already running a little late. If you have to get going, we totally understand. We're sorry. We'll try to be better on our next one, which is in 2 weeks. Yeah, you get to be blinded by my melon in 2 weeks again, if you're willing to come back.
Yeah, thanks, Drew. Thanks, Jeff. I think we'd have a question about the BEAD rules. We'll go over that one real quick if you have a minute. So with the change in BEAD rules to make the last mile technology agnostic, how does that change the architecture overall for the middle mile? Does it play to keeping the middle mile and last mile networks separate? How do those rules affect things?
Honestly, I think it increases the importance of building the intelligent middle mile, because you're going to have competing technologies running right next to each other, whether it's the RAN access network that's used for fixed wireless access, or it's the PON network, or in rare situations maybe a ground station from that LEO satellite internet. That whether you're backhauling that or it really, middle mile does that. It backhauls everything to the internet.
And whatever your access technology is, right? It's underlying everything they all share is that eventually they're getting on a fiber network at some point. So even whether it's fixed wireless, 5G, 4G wireless, PON, heck, DSL, whatever, right? Eventually it's gonna jump on a fiber backbone middle mile network. So yeah, I don't think that it certainly doesn't reduce the importance of a middle mile network. I think it just changes what it might hold or what it might connect to for an access technology.
It kind of underscores the importance of the technology agnostic need for that part of the network.
Gotcha. Thanks for that. We had a couple more, but I think just in the interest of time, we'll handle those sort of offline. I think any last minute closing comments, I guess, Drew or Jeff?
Thanks for coming, everybody. Don't forget the 7:30 show is completely different from the 9:30 show. Don't forget to take your waiter.
Yeah, tune in in 2 weeks. So thanks again for joining today. Really do appreciate your time. We know it is a long time, but a lot of good content here. Please look for an email from us later this afternoon. It'll have a link to the replay, a copy of these slides. You can reply to that message if you have any questions or things that you think of after we finish the call today. Again, you'll get another email about the next webinar in the series, so expect that to come in the coming days. Again, we always appreciate your time and look forward to talking to you on the next one very soon. Thanks, Jeff. Thanks, Drew. And thanks, Elizabeth and Mitch, for handling the questions on the back end. Have a great day.
Thanks, everybody.
Thanks.